Now, we've worked with roots in the past, and now we're going to kind of work with higher degree roots. We worked with square roots and all that good stuff. Now we're going to work with cubic roots and fourth roots and fifth roots and sixth roots, etc. So, for a couple things we got to talk about is some properties that we've used before. The words for the properties are not that straightforward because it seems like you're just using the same words over and over. But the first one says the nth root of a product is equal to the product of the nth roots. What that really means is, if we're looking at this example, if we have the cube root of 16, we can break that up into the cube root of 8 times the cube root of 2. Really, that's just saying we can break it up, and instead of 16, we can factor it out into 8 times 2. The reason we would do that is because this cube root of 8 here simplifies to just 2. Now we're still left with the cube root of 2 here, but that's okay. At least we got something out of our cube root. Now for the quotient property of roots, it says the nth root of a quotient is equal to the quotient of the nth roots. Again, not terribly useful unless you're actually using an example. So the example that they have here is the square root of 25 over 16, which means you can break that up into the square root of 25 over the square root of 16. So again, just like we did with the product above it, you're breaking it up into smaller, more manageable pieces. Now let's take a look at an example of this. On example number 1, we got two examples. We've got the fourth root of 81x to the 12th. What we're going to do is, first of all, break that up. Let me zoom out a little bit. Break that up into the fourth root of 81 times the fourth root of x to the 12th. Fourth root of 81 is just 3, because 3 times 3 times 3 times 3 is 81. Fourth root of x to the 12th. Now I'm going to show you something that we haven't done in a while. When we're taking roots, the fourth root can be written as also an exponent. Instead of writing a fourth root, we'll write it as to the 1/4 power. Now, just like we've done in the past, when we have a power to a power, you end up multiplying. So we get 3 times x to the 12 times 1/4 is to the third. So 3x to the third. Over on our other example, same type of deal, ending up working with fourth roots again. So we got the fourth root of 16 times the fourth root of x to the 8th. So we're going to break this up. Fourth root of 16 is just 2. Fourth root of x to the 8th, we have x to the 8th, and we're going to raise that to the 1/4 power. Multiply 8 by 1/4 to get our new exponent of 2. Now, in both these examples, the exponent and the coefficient happen to be the same thing. That's not always going to be true, but it just happened to be in this case.